Okay, so looking at number 41, what we're given is the fact that we have a mass of 2 kilograms, and we're given its position function as being 6 I hat plus 5t j hat. And our goal here is to find out the angular momentum. Now, quick reminder, the angular momentum is the cross product between the radius and the regular momentum. So I need to find out I know the radius, I need to find out the regular momentum. So the way I'm going to do that is, since I'm given the position, I recall that if I take the first derivative of my position function, so dr dt, that will give me my velocity. So if I take the first derivative, the I hat, since it's 6t to the 0, so that's going to go away. But I've got 5t to the first, so that's going to end up giving me 5 j hat is going to be my velocity function. Because the 6, since this is t to the 0, the I hat terminology or term goes away, and this t goes from t1 to t0. Okay, so from there, now I can solve for my momentum. Momentum, remember, is just mass times the velocity. And so I know the mass is 2 kilograms. I know the velocity is 5 j hat meters per second. And so my momentum of my object is just going to be 10 kilogram meters per second in the j hat direction. Now, the direction is important because, remember, we have to do the cross product of these. So cross product, what we're going to do is we're going to set up our cross product formula. So I hat, j hat, k hat is our first line. Our second line is r, so this would be 6, and then 5, and then 0. And again, notice I get rid of the t here because I'm just looking at that one spot. Now, my momentum, that's 0, 10, 0, okay, because the 10 is only in the j. So if I do the cross product of this for my I hat, and I'm going to do this all out so you can see it done. For my I hat, I'm going to go 6 times 0 minus 0 times 0. Okay, so then end up giving me 0. So I'm going to have 0 in the I hat direction. For my j, I'm going to go for the j, it'll be 6 times 0. Oh, yep. Oh, I did that wrong. This should have been 5 times 0. My fault. Sorry, 5 times 0, not 6 times 0. And then this would have been 10 times 0, but the end result is still 0 in the I hat. So we have these two minus these two. So I screwed out the first one up. For the j, that's the one I originally did. For the j, it's going to go 6 times 0, and then I'm going to subtract off 0 times 0. So again, there's going to be 0 in the j hat. Okay, and now if I do my k, now I'm going to do these right here. So this would be 6 times 10, minus 5 times 0, and so this is going to give me 60 in the k hat direction. And so the cross product of L of R and P is going to be 60 k hat. Now, interesting enough, notice that this, because it's in the k hat direction, is in the exact perpendicular spot as to my momentum, which was only in j, and to my radius, which was in I and j. So remember, when you do a cross product, the result has to be perpendicular to the other two. So my final answer, L is 60 k hat. I should put units there, kilogram meters squared over seconds.